Welcome back in the part 2 lecture of the carbonyl compounds. As I mentioned, carbonyl group is present in 4 different families in our syllabus: aldehyde, ketone, carboxylic acid, and esters. We discussed today the aldehydes and ketones because they are very comparative to each other. I just made 2 different parts so that they don't confuse each other, and both parts today so the both can be compared later on. Okay. In ketones, the mentioned group, the carbonyl group, among the 2 valencies, both are satisfied by the alkyl group. That's the difference between ketone and aldehyde. In aldehyde, carbonyl will be found always on the extreme right or on the extreme left. But in ketones, the carbonyl group is between the 2 alkyl groups. Rest is same. You can say RC double bond OR, or we can also write RCOR. These both are the general formula of ketones. All aldehydes follow their general formula except formaldehyde. But there is no such thing in ketones. All ketones follow this formula. The most basic ketone will be one in which the both alkyl groups will be smallest. And what is the smallest alkyl group? Is it ethyl? No, it's methyl. So if you put 2 methyl groups around the carbonyl, now this is the simplest ketone. This ketone is represented like this, or you can write CH3CO CH3, or you can go CH3 C double bond O and CH3. All are the ways. This is the simplest ketone. Now, there are 2 namings, common and IUPAC. Common I will put here. In common naming, it's called dimethyl ketone. Yes, just like ethers. Dimethyl ketone, 2 methyls ketone. There was in ethers dimethyl ether. Here it is dimethyl ketone, right? But in the IUPAC naming, we number the chain, right? 1, 2, 3, same from either side. Normally, we will number the chain from where the carbonyl is nearest. Okay, so the carbon of carbonyl must get the smallest number in value. This is 2. Okay, 2 propa. Why propa? 3 carbons. Ketones, their suffix is on. So you just write the propane, right? Just don't write the E and replace the E with O-N-E, because O-N-E is the suffix of ketone, propanone, 2-propanone. Okay, you can write propane without E, 2-1. Also same thing. All right. So 2-propanone or propane 2-1, also called dimethyl ketone, is the most important ketone, the most basic ketone, and the most famous ketone. It is called basically acetone. The commercial name of this compound is acetone. When I say commercial name, like if you go buy this chemical from the market, and if you will ask them 2-propanone or propane 2-1 or dimethyl ketone, they won't respond to you because this is called acetone. Now the word acetone, again let me clear why this is called acetone, because this can also somehow convert to acetic acid. Now this acetone is basically directly used as a nail polish remover in our houses, right? Which proves that it's a very strong solvent. it can dissolve the plastic, the paint of the nail polish very easily. So this is acetone, my dear friends, the first and basic ketone, dimethyl ketone. How about this guy? CH3, C double bond O, CH2 and CH2. Just like if this is dimethyl ketone, this is ethyl methyl ketone. Again, you will find the naming is just like ethers. Ethyl methyl ketone. IUPAC will say number the chain from the side where the carbonyl gets the least number. So 1, 2, 3, 4. What is this? 2, yeah? 2 propa or buta? 2 butanone or butane 2,1. Easy and very simple. Okay, let me give you more examples. CH3, okay, and let me make it this one downward. CH3 and CH3. What is it? You know this from diisopropyl ether? It is diisopropyl ketone. Diisopropyl ketone. But IUPAC says longest chain and numbering. So once again, 1, 2, 3, 4, 5. Do you have branches? Yeah. At 4 and at 2. So first you indicate the position and the name of these alkyl groups, right? Help me. Yep. 2, 4 dimethyl, right? 3 pentanone, right? Super easy, even easier than ethers is ketones, right? If you have a common name and you have to write the structure, just make the 2 alkyl groups on both sides and put the carbonyl in the middle, just as you have done it for the ethers. You can write C double bond O going upward or O going downward, or O in the same ring, same, you can say chain, CO, right? Few more examples. Now you guys are expert of this naming. Hope so. Now this is isobutyl. This is carbonyl, right? And let me make it more little bit confusing for you. Okay, here we go. I put a new pentyl, 5 carbons. Now this is new pentyl, isobutyl, new pentyl, ketone. Right? What is it? Isobutyl on one side, neopentyl on the other side, and it is ketone. And for IUPAC, you have to number. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. Other side. Okay. So 1, 2, 3, 4, 5, 6, and 7. Position of the alkyl groups alongside their names. There we go. 2, 2, 6. How many methyls? 3. So trimethyl. Where is the ketone? On number 4. And what is the number of carbon? 7. So 4 heptanone. So my dear friends, you have found that the naming of ketone is very much easy for those who have named ethers. And basically they all follow all rules of alkanes. But this is fantastic. This is very, very easy. So if you have a name, you can write the structure very easily. If you have a structure, you can name it very easily. So both way, it's an easy game. It's a very easy game to do. So we will jump to the assignment directly because now I guess things are very, very clear already, and I don't want to just waste your time repeating same thing over and over again, I will take you to page number 212, right? And page number 213. 212 has names for which we write structures. 213 has structures for which we write names. So we had finished the ethers at number 18, and 19 is a ketone, and then 20 is a ketone, right? And 21 is a ketone. 22 and 23 were aldehydes, I gave you already. But 24 is a ketone, and in fact 25 is also ketone. So you have to draw their structures. Names are mentioned in the book on page 212. Now let's go towards structures and how to write the name. So this is on page number 213 and question number 4, and up to 12 were aldehydes is 13, 14, and 15. So 13 to 15, they all are ketones, and you have to write the name of them, right? So before I end this lecture of naming ketone, I would like to take 5 more minutes and explain the difference with the biologically important compound. Although I have discussed this already in my lectures in the classroom, but I would like to again focus on this, okay? And this is about glucose and fructose, right? I told you about these compounds. Both glucose and fructose are carbohydrates, very famous carbohydrates. They both contain 6 carbons. So 1, 2, 3, 4, 5, and 6. Fructose is also same, 1, 2, 3, 4, 5, 6. So both fructose and glucose have 6 carbons. Their molecular formula is C6H12O6. So glucose is also C6H12O6. Fructose is also C6H12O6. They are basically functional group isomers to each other. And how is that? In glucose, the carbonyl compound is on 1 carbon, always first carbon. In fructose, it is on the 2nd carbon. So you can see glucose by here chemically is an aldehyde, and fructose is chemically a ketone, right? Remaining valencies are filled with OH and H. So, right? And OH, H, H. There are many isomers of glucose here. I'm not giving that head here. I'm just writing a simple isomer of glucose here, CH2OH. So there are many OH groups in aldehyde. Similarly, fructose, CH2OH and CH2OH, right? Remaining have the H, OH, OH, H, and HOH. So if you guys are wondering how is fructose and glucose both C6H12O6, is because they are isomers, compounds with a similar molecular formula but different structural formula. Now let me help you here again. This glucose, chemically it is called aldohexose. Why aldo? Because it's aldehydic. And why hexo? Hex, because of 6 carbon. And why ose? Because this is the suffix for carbohydrates. Maltose, glucose, fructose, ose. So aldohexose is the chemical name of glucose. However, there are many isomers, the alpha, beta, plus, minus isomers, but this is the simple one, aldohexose. Now, can you tell me If glucose is aldohexose, what is fructose? Yeah? Ketohexose. Why keto? Because keto, because this is ketonic group, hex, because of this carbon, and ose, because of the carbohydrate. So the if you are eating sugar, most of us are eating sugar. Glucose is the number one or basic energy, like petrol for cars, glucose for us and our brains. Our brains exclusively feed on glucose. Our bodies too make energy from glucose. Now, glucose is present in starch, which is rice and chapatis and all this, potatoes, rice, glucose, where it starts as a polymer of glucose. So our body will break it down to monomers, which is glucose, and then this goes to the bloodstream, and our cells make energy from it. Fructose, however, is not directly metabolized as easily as glucose is metabolized. So when you're eating sugar, sucrose contains both the glucose and fructose. This guy is used by the body and this guy is stored as fat. So this is the harmfulness of eating lots of sugar. So this ending lecture, basically, I had said earlier I will make a lecture comparing lecture 3, but I think the job is done here. And today your task is naming of aldehydes and ketones and share them with me. Before I end my lecture, I will just say some ending words here. This the lecture which I'm giving here. If you download it or if you watch it, and you are thinking you have become Einstein, no, you're not, okay? Just watching the video will not make you Einstein. Even it will not make you a good student of class 12, all right? Even if it will never help you to get A1 grades, even selection. It is the 20% of work that is done, which I do. The remaining 80% work is based on you. If you really think that just watching a video is 100% effective, not so, okay? You have to put them into your brain and then through your brain to your hands and from your hands to a paper. This is called reinforcement, okay? You reinforce it and then you all send me, okay? Now, I checked 512 unread messages on WhatsApp on Saturday, which was kind of a lot, but I really liked it. So when you will do your work and then you will share it with me, then it will become 100%. Then it's still not 100%. I do 20% and then you do 50%. So it makes it becomes 70%. Remaining 30% is done when you do it without watching the book or lecture the way we have a test. So on Friday, we will have the test of aldehydes and ketones. Preparation and properties of its compounds. And so you should try to work it out and please show this with me. And the main purpose of these video lectures is to engage and enhance the student-teacher workforce. It's just to bring the student into the teacher's attention and teacher's work into the student's attention. It's just the video, it's not everything. All right, thank you so much. Do your work and kindly share with me. Goodbye.